Yep, that's me. You're probably wondering how I ended up in this situation.
The wheels of the bus go round and round, round and round, round and round. The wheels of the bus go round and round. The electrical engineering department at UCT organized an excursion for us to visit the Sterrekus Substation located just outside Cape Town and forming a key part of the Western Cape transmission network. The Sterrekus Substation is part of a 765 kilovolt transmission network that stretches all the way from Mpumalanga to the Western Cape.
This is what I imagined. I knew I wasn't dreaming. You're like, wow,
You could feel the excitement, but at this point we didn't fully understand just how massive the system we were stepping into actually is. We were introduced to the facility by Ettienne Scholtz, a senior HV plant specialist, and what stood out to me is that bro does this voluntarily. Like, he willingly takes time out of his very busy schedule to inspire the next generation of engineers. And it makes you think, how many industries rely on people like him to pass knowledge forward? Transmitting power from Mpumalanga all the way to the Western Cape is a mammoth task. These places are over 1,200 kilometers apart. Compared to the existing 400 kilovolt network, 765 allows far more efficient bulk power transfer over long distances. Interestingly, the 765 kilovolt expansion wasn't always a priority. Back in the 1980s, Eskom actually had a surplus of electricity, so expansion to these ultra high voltages was paused. But by 2006, demand had already caught up, and suddenly the need to move large amounts of power across the country became critical again. And that's when the 765 kilovolt transmission line project was commenced. Alright, let's take this conversation outside.
This transformer doesn't come like this. It gets assembled on site. The main tank.
Now, here's a question for you. How much money do you think Eskom saves by using the 765 kilovolts instead of lower voltages?
About 1.3 million rand a day that you save.
Well, here's another question for you. How much do you think it costs just to paint one of these transformers?
3.6 million.
And that's when it really hits you. In industries like this, it's not about working hard. It's all about specialization.
Very specific application methods that you need to do. Specialized people. Now, once you are specialized, you make your own currency. That's how it works.
That's the reality of it.
Specialized field. Guys, high voltage industry, nothing in it is cheap. Nothing. The more specialized, the more expensive. To give you an idea, in a gas insulated substation, I had to buy a T-piece connector. Now, a T-piece connector is basically installed within SF6. Nothing fancy, it's an aluminium block that is machined. It's silver with a couple of holes. Any engineering firm can make that for you. A block this size, 650,000. For aluminium, that's just silver tin. But you may not buy it from anybody else but the supplier.
Is that a standard?
It's not just the standard, but if you want to maintain your guarantees and warranties, you've got only one route to go. And because
Now, infrastructure like this is critical to South Africa's grid. That's why the National Transmission Company of South Africa introduced the Transmission Development Plan, TDP. They've earmarked around 112 billion rand over the next 5 years just to expand and strengthen our transmission network. And this becomes even more important when you consider South Africa's long-term energy plan. According to the integrated resource plan, a large portion of the coal fleet will be decommissioned over time, which raises a critical question. Where will that replacement power come from? And how will it get where it's needed? Because most new generation, especially renewables, won't be built where old coal plants were. It needs to be transmitted across the country from the likes of Northern Cape, Western and the Eastern Cape. I've linked the transmission development plan as well as the integrated resource plan in the description if you want to explore it further.
In the high voltage field, in relation to the low voltage field, what is the ratio? Your 1 to 20? So, in principle, you make up a very small group nationwide. If you take all the universities that actually presents high voltage or heavy current electrical engineering, and you need to understand the need for that in the business, in the country. Is currently there's under delivering from the university into the market in that field, and that makes you highly employable. That you need to understand. So it's a very good field to be, and very interesting. So I always say, the day you start to die is the day that you haven't learned something.